Okay. Yeah, I'm just going to say hello, welcome to workshop 3, and just to introduce everything. So my question was, what are the different ways you can present your AI model to somebody that probably is non-technical? And I think one person mentioned about like Streamlight, which is like a Python, a library in Python that permits you to define UI. So most of the time when you need to like implement some UI, you need to know some JavaScript, but stuff like Streamlight permits you to like build UI using Python. So yeah, this is a very good example. I know there's something else, but I've forgotten the name that is like Streamlight. But there are a lot of libraries like this today. But today, what we are going to be looking into is how you
Hey,
can probably like,
a couple
yeah.
other people mentioned a couple other ones.
Oh, oh yeah, Gradue. That's what I was looking for. Yeah, Gradue is very cool. I've used Gradue a lot in the past. I think Gradue is actually simpler than Streamlight. If I'm not, yeah, Gradue. I think a lot of AI models like usually use Gradue because it's very straightforward as compared to like Streamlight. So yeah, Gradue is also like an option you can use to like present your like what your model, what you've built. So Streamlight, Gradue, and I think there are a couple of other stuff, but um today I really wanted to like introduce you guys how to like implement like an API, because an API is usually very universal. When you build an API, it means somebody that is using whatever stack, it could be JavaScript, it could be Python, the person can always like reach out or like call your API. Just like OpenAI, they have like the API, which no matter what language you're using, you can access it. And that's why I really wanted to like introduce you guys to like probably like should I say backend development or wrapping your API into a backend. So from 1 to 5, 5 being like you know backend, and 1 being like you have no idea of like backend. How like I would like to know like the knowledge of like the participants, like how good with backend are you? So I should tailor my explanations like based on that. Oh, okay, that's 1. It's going to be tough, but okay. I guess we're going to start. That's 4. Okay. 2, Node.js and Django. Yeah, that's good. Think we're going to need this. This is from the other week. Yeah. Okay, so Flask 1. Okay. I think some introduction will be great. Think, excuse me. You have the database, you have the controller, and you have the view. Model. It's usually controller, but let's say model view and model controller and view. Um, yeah, so I think I'll just give like a little bit like an intro to like backend development, if I can say that, for people that probably like do not really know what backend development is, or how or what we are going to be doing. So most framework or backend framework, I think everybody have an idea of like what backend is. Backend is usually like the logic, or it's usually the part of your application that runs the logic. So if you have an application that returns like it's just like an addition for summing numbers in the backend, the code that actually sum that does the 1 plus 1 or the 2 plus 2 is going to be running on the backend. And usually the backend runs on the server side. So let me give an example. So the client side is the browser, which is, for example, if you see this page I'm on, this page is tail drop, or like it's what I use for like sketching. It's on the client side because it runs on my browser. But what you usually have is like the backend. The backend usually runs on the server on which the code is running. I hope I'm not making it too complicated. How can I show this? Yeah, the backend usually runs on a separate server. So what good example can I show here? I think I'll just use bridge apps as an example. So when you're like your backend is something that always runs. So the point is that number one, your backend is an application that should always run. Number two, it's something that somebody can access from. Ideally, somebody should be able to access from wherever they are, depending if it's like a public API. So the goal of your API is to make sure it's always running, and you cannot put your API probably like on your local PC because your PC can go off and whatsoever. So most of the time, people usually like deploy their API on different services. It could be DigitalOcean, it could be Heroku. I think most people are familiar with Heroku. It could be AWS, and you choose to deploy your API or to have your API run on those services because like those services or those servers or those computers are always running. It means whatever, because like you might deploy your API for usage. Let's say you have like a web application or your app. You don't want that when somebody in America is trying to like access your app, the person is not able to access your app or the app is down. So ideally, you want to put it on a service that is always running. That's why people usually use like hosting services, because the hosting service makes sure your app is always running. So the backend usually runs on those services, but the front end is usually rendered on it's usually rendered on like the web. That's what runs on the browser, and that's why you need a browser. So the backend is usually constitute of like three main things, which is what is this? Yeah, three main things. The model, we have the model, the controller, and the view. And most people, it's usually abbreviated MVC, 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 yeah. Yeah, it's usually abbreviated MVC. So it's like an architecture that permits you to like separate your. I'm going to briefly explain what each of them mean, but it's just like an architecture or like a way of like setting up or structuring your project that separates like the data layer from the logic layer from what people see. And most frameworks adopt that. So a very good example is probably Express.js, Django, and a lot of couple of other frameworks. Because if you're a backend developer, you're going to notice that for each framework you use, there's always going to be a file where you define your model. There's going to be a file where you kind of like define the logic of your application, and there's going to be a file where you return it. Now, backend frameworks like Flask or FastAPI, they have like a very simple way of just like defining everything in a single file, but but that does not mean it does not like respect like MVC. Yeah, cPanel is also like another way of deploying your application. cPanel is mostly used for like PHP application, and yeah, I think you can use. It's a little bit complicated to deploy like other applications other than PHP. But if your app is like runs on PHP, then yeah, you can easily deploy it on cPanel. Yeah. Okay. Yeah. Node also. Yeah. I think yeah, Railway is a good example. So what I'm trying to say is like in the backend, you usually have where you define like the definition, because for example, if you have data in a database, you want to be able to like retrieve the data from the database. If you have like a list of product, your model is where you define the structure of your database and how the structure of the database. Probably I should pull up an example here. Yeah, so the model is where you define like the structure of your um, it's where you define like the way you want your database to be. Okay, I'm not even sure. Um, yeah, I just want to show an example here. Like I just want to give you guys like a quick overview of what it means like backend, and then I'll briefly talk about what we are doing today. So what's a good example? I think the very that their portfolio. So in the models file, you usually like this is a Django project, but I just want to show, I think everything should be here or not, probably here. Models. So Django is a very good example. Models in Django, you usually have the models.py file, and this is where you define the structure of your database. So for example, this is like a model I'm defining. It's like a structure or like a field on my database, which means I'm going to have a name, which is a character. I'm going to have another field, which is called greetings one, which is a character. And that's where you define like the way your data is going to be saved. Next, you have like the controller, which is where your logic runs. So sometimes you can have applications that have like a controller and a view without necessarily having a model, because maybe, sorry. Yeah, sorry about that. So I was saying sometimes you can have a backend that works without the models, because maybe your data could be coming from somewhere else. Your data could be coming from another API, or your data could just be like a model. So for example, in our case, what we are going to be building is just going to be calling like the AI model, and we don't necessarily need to like save the result. So you can have like a data source without calling, like having your own database. So what you usually have here is the logic, the business logic of your application. And in our case, like we have built a model and we have built like exported the .pt file, that other formats for like models, but we have exported the file of the model. So in the controller, like where you have like the business logic, what we are going to be doing is we are going to be loading the model in the controller and then getting input from the user. So the view, you can kind of say, the view is not always like what somebody can see, but it's kind of like the layer through which somebody access your application. So here we are going to be inputting like let's say text. We are going to be input like upload the text. Let's say upload. We are going to upload some text and an image, and then our backend or the controller of our backend is going to process it, that is load the model and try to run an inference, then I'll return it back to the view. And that's basically what we are going to be doing. So I just wanted to like quickly introduce that a backend usually have like the model, which is directly attached to a database, but then you can have an application without the model, just because maybe your data source can be coming from somewhere else. It could be just, I don't know, it could be from another API. It could be maybe from a CSV file, if necessary, because sometimes you don't need to like have like a full-fledged database for you to like run an application. And so that's basically what we are going to be doing. So we are going to be implementing a backend with a controller and the view, so that we can send information or like upload an image. Then the controller of a backend actually loads the model, run an inference, and return the result to the person that called for it. So I'm going to pause right there and see if there are any questions. Okay, I see one here. Can you explain inference? I have been hearing about it a lot. Okay, sure. I'm going to explain inference. Is controller same as serializer in Django? No, the controller is not serializer in Django. Like this is Django specific question, but a serializer is just what tries to like it structures the data. It serialize the data. That's not the way it's defined. A serializer is, for example, like in Django specifically, a serializer is what, if you define your input, I think we're going to have an example here, but it's not going to be a serializer. If you define your input to be an image file, right? In Django, you like the serializer is an object you create to be able to validate if that input, if the input from the user is actually a a file, an image file. And in the other way, a serializer can be used to prepare your data before exporting it or before returning it. So if you have an object if you're getting objects from the database, you can have the serializer structure it in the way it's going to output to the API. So I think that's more of like a Django question. So I'll not dive deep into it. So inferencing is just basically like it's a way of how do you define it? I'm not sure I know the definition, but I don't know like the actual definition, but inferencing is just like probably we should Google the definition. Yeah, let's see what Google says. Inference is the process of reaching a conclusion. Okay, inference in AI. Yep, inference is a process where a trainer applies his knowledge to new unseen data or make a prediction. All right, so just based on this definition, like inference is a way, like let's say for example, you have a model. Inference is a way of calling that model to get a result from it. So one very good example is getting a prediction. If you have a model that predicts if an image is an image of a cat or a dog, to run an inference means you send an input into the model and then the model gives you an output. So that's basically what inference means. Like the JSON structure. Yeah, serializer is just a way of like preparing your data either for output into the wall or receiving into your controller. So it's just a way of like you can use it for verification and also like structuring your data before outputting it. So it's just like an object that permits you to wrap information and return it in the appropriate format. Is inference the same as MCP? What's MCP? Can you define that? I'm not sure what is MCP. MCP has multiple meaning. Model context protocol. Open standard for AI systems to interact with XNOT tools. Is this okay? Model context protocol. It's like an API better with AI. Is inference? No, inference like just I'm not familiar with like the model context protocol, but if it's a protocol, I know what the protocol is. But inference, like I said, inference is just the act of calling your model to make a prediction, or you can put it simple. It's a way of like sending an input into your model, and then the model gives you an output. Now, from what I'm seeing, the model context protocol, when like a protocol is just a way of communicating. So if it's like just based on this, what I'm just reading right now, from what I'm seeing, it seems like it's a way of quickly sending messages between different models. So if you hear of protocol is just a way of exchanging messages. Yep. Roy, you can go ahead.
Yeah, thanks. So you mean with inference, right? To
Yeah.
infer, like it doesn't mean like to inquire or to investigate or something like that.
Not to investigate, but to inquire, you can put it that way.
Inquire. Okay.
Yeah.
Okay.
Yeah. So it's just like you're sending an input and you're getting an output from the model. Because when you talk about invest, but it could also be investigate in some way because you can send an input to investigate the output, but at the end of the day, you're sending an input you're testing a model to get the result or to see what the output is. Yeah, Nuru, you can go ahead. I think with data, it has not been seen before. It must not be data because you can influence with data that's
Yeah.
already seen before.
Sorry, can I speak?
Yeah, sure.
Yeah. So I think I was saying it in the comments. So inferencing is basically like querying the model, a model after training, querying it to give an output. So for instance, just asking ChatGPT a simple question means you are inferencing it. Whether
Yeah.
it's in an image or text, you are simply inferencing it. But MCP on the other hand is like MCPs. I mean, for AI is okay, very clear now. Okay, so MCP for AI is more like giving AI the ability to make certain calls. So it's just like tool calling, right? So an MCP for let's say super base will serve as like a functionality for the AI to be able to communicate to Superbase via some protocols. So instead of you to go to Superbase and create some tables yourself, you can let an AI do that via the Superbase MCP. So you're just giving AI the ability to make certain calls. So like the Google Drive you have here. So if you wanted to upload an image to Google Drive, if Google Drive has an MCP, it's just a protocol for you to upload an image using an AI. So that's simply what MCPs are, and that's what like inferencing is.
All right, we'll take one question, and then after that, I know Regina Esen and Hamdani Gandhi, you guys said one, so I'd like to take a question from you and know like if you have any question regarding backend or what we are trying to do today, so that I can try to explain better. But yeah, Godfrey, go ahead.
I just wanted to add up to what Nuru was saying about the MCP. I don't know much about it, but I followed the YouTube tutorial, and then what I ended up doing was that I shared my API link with DeepSeek model, and then DeepSeek model was able to, based on my API, and then was making predictions on probably unrelated routing for people to make estimation. So I really thank Nuru for his explanation on that. So I don't know much about MCP, but I think I will read more about the Infer and see how to implement it, and then probably talk about MCP later.
All right, yeah, sounds good. I think it's interesting. I don't think I've had to like really dive into this, but I think it makes sense. So I want a question from Regina and Hamdani. Sorry if I'm not pronouncing your name very well. But I hope everyone's like on the same page, just like trying to like understanding what backend is and what we are trying to do. Typical use case of serializing Django is when it's been created, transform Python object into JSON. Yeah, I think that's yeah. Probably I'll just go search the response. It transforms Python objects to like JSON object. So either you're trying to like if you're trying to receive like a JSON, you can also do it in the reverse, I think. But it's mostly like you have a Python object. It's just an object that permits you to convert it into a JSON. And JSON is it's a way to it's mostly the way that's the way data is being exchanged through like with REST APIs. It's what you are describing. Inference basically making prediction like model that predict. Yeah, inference is like making a predict. Like inference is also like making a asking a model to make a prediction. So seems like there's no question for now. I think I'll just like proceed. So like I was saying, what we're going to be doing today is like trying to create a controller which can, excuse me. We're going to try to create a controller which is going to be, we are going to be creating an inference API. And what an inference API does under the hood is the controller part of our backend is going to load the model and then ask it to make a prediction and return that to the user or to the person that queried it. So I know like most people might be wondering why probably I'm using FastAPI versus Flask. I know most people are usually familiar with Flask. How do you spell it? Flask? Yeah, Flask versus FastAPI. So you can read a lot about like maybe like using Flask versus FastAPI. And I think there are a bunch of stuff you're going to find there, but FastAPI is fast or faster than FastAPI than Flask. So I think I'll stop there. I don't want to dive into like a lot of explanation, but FastAPI is usually faster and it's usually used for performance critical application. And since we are going to be loading like a model, I have the model here, and the model is like 1 GB. So yeah, I have the model here. So this is a model I trained earlier today. It's 1.6 GB. So usually you can use Flask for this, like for this scale of application, it's fine to use like you can use Flask or FastAPI. But FastAPI is usually best because like it's faster I'm going to keep on saying that. And it has like, it's usually more performant as if you want to compare it with like Flask. I think there are a lot of better explanation you can find about that. But at the end of the day, it's very similar. What we're going to be doing is something you can easily do with Flask. So I think, can we jump into code right now? So if you want to see like the resources for this workshop, you just need to like check the GitHub repository, and you're going to see everything here. So I'm just going to walk you guys through how to like set it up. Virtual environment, I don't know if I have to explain this, but a virtual in Python, when you're using Python, you're going to usually encounter like a virtual environment. It's just a subsystem, or just a space where you install dependencies, which means that if you're using PyTorch 1.2 and you have another project that probably requires just PyTorch 2, you can create a virtual environment to install PyTorch 1 point something, and you can like install another virtual environment to install PyTorch 2. And in that way, you can run like different application that has different requirements. That's what you're going to see in Python most of the time. You need to create a virtual environment, and then you have to activate it. Activating just means you are going to be using the dependencies from that environment. So yeah, I'll not, oops, I'm just pulling up my shell now. Yeah. Deactivate. I think during the first workshop, I kind of mentioned like a virtual environment. You can like a couple of ways of creating like a virtual environment. You can use the default Python VNV, or you can use Conda. I think at the end of the day, all of them work the same. I've not really found I think I usually use Conda when I find any AI project that uses Conda, and it's usually simpler to like just install it with Conda, because they already have like everything. Their description is usually in Conda, so I just like follow the step-by-step process and I use Conda. If I find one that uses env, I just use env. So activating a virtual environment is just a way of saying that I'm going to be installed. Any package I'm installing is going to go into like this virtual environment. I think I explained a lot on that during the first tutorial, but just can we please get the link to the GitHub repository? It's showing, yeah. Let me drop it in the chat and show you where you can get the link. So if you go to the Ghana AI Hackathon document, which you can find on the notebook, yeah. I think the notebook LLM, I know this link is probably like everywhere, but if you go on the notebook, you're going to see that we have this Ghana AI Hackathon notes or document, which
I'm
when
going
you
to
come
drop
here.
that. I'm going to drop it in the chat right now, the notebook. So go ahead.
Okay. All right. Thank you. Yeah. So there are two things we need. So I think we should first of all visit this model. So I'm just going to be using the model we trained last week. For the model we trained last week, you're going to notice that where is that? We are creating the model. Where is the model file? Yep. We need the seed, we need the image, and we need, so yeah. For most of the time, like for the model we created last week, we exported it as a PTH. I'm not sure why that extension, but I know that's usually the way models are exported, PyTorch models. So what I'm trying to show now is the resources we need to like run an inference. I thought that was here. Okay, this is it. Yeah, this is the function. Yeah, so if you check the model, there's like if you check the workshop Kaggle or the notebook, at the end of the notebook, you're going to see that there's a function that is called run inference, which loads the best model. Yeah, it loads the best model. It uses PyTorch to torch.load the directory of the best model. It loads the best model, and then we run an inference on that model. Yeah, where is that? So we have model, yeah, and then we run an inference. So here we run the prediction. So this is the model we loaded, and what we pass into the model is the image and the text. So this might differ depending on your what you build, but the goal here is like we are loading the exported file with PyTorch. This is the way you load. Usually like just, yeah, you load the model and you load, like you set the model in evaluation mode. If not, it's going to be in training mode by default. And at the end of the day, you just try to like get the image, and then also like this is the tokenizer. I'm not sure if I need to explain more about that because it's really specific to this project. But the point is we get the image and we also get the text for the model. And then what we want to do is we want to pass it into that model and then get the output. Then yeah, just try to like get the prediction from the model. So we are basically going to be building, I was talking about that because we need the checkpoint models. That is the best model that has been trained. And then we need this mapping JSON. So this mapping JSON is just a JSON file that contains, let me just pull up. It's just a JSON file that contains all the classes of a model. So if you see like apple pie is 0, blah 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 is I don't know, ramen is 81. So usually the model is going to return like return a number, and then we are going to use this JSON to get the equivalent of that number. That is, if it's 20, then it's chicken wings. And yeah, so we have the required files for our model is number one, we need that model, and then we need this file to actually like get the equivalent class of the model after running our inference, because it's just going to return us a value like 20 or 22. So we use this file to just like get the equivalent for this. So if you want to get the files for this to run this, you just click on this link and you have it, like you'll be able to download it. I think this link is wrong. Yeah, this link is wrong. Let me just get the right link. Yep, best model. Yep. So you just need to click on that link and it should download. Yeah, that link is wrong. Yeah. So you just need to come on GitHub. You click on this link. This file is like, I don't know, it's less than, it's 500 byte, I think. But this one is like, I think it's 1.9 gigabyte. So this is usually what is heavy from, like the model is usually very heavy. So you need this. And what I have gone ahead and done is in FastAPI, just like in what's the name? Just like in Flask, you usually just have you don't need to like set up a lot of files like other bigger projects that they usually like have a simple way of like defining an endpoint with a single file, and that's what we are going to be doing here. Yeah, and then if you see here, I've downloaded my class mapping.json, and also in my checkpoint folder, I have downloaded the model. So I also created a script. So if you run this script, update model, if you run this script, so once you get like the folder, the workshop 3, I'm just going to do ls here. You can run this script, which is called update model. I think if you're on Windows, you are going to have to use something else. I think the command is slightly different. I don't remember. It's been so long I use Windows. But I think if you're using Windows, is it Open Linux system? This is something Linux system for Windows. Yeah, you should have the same. WSL. Thank you. I guess I'll just go with that. But if you're using WSL, this command should be the same. So you just need to do bash update model.sh, and it's going to go ahead and download all the required files for you and put them in the necessary positions or directories. So I might have gone really fast, so I'll stop there and see if there's any question. If there's something I did not explain very well, please ask a question and I'll try to explain better. Also, I know there were two people last time that mentioned they wanted me to like go through like a project or like a mini project that talks about maybe like transport data or how we can handle like the type of data we have for project 2. So for that, I'm going to I don't know how we can do it. Kevin, I want to organize like a bonus session probably on Saturday. I think that should be maybe 10 a.m. Ghana time to go through like a sample project that makes use of like a data set that is like the Ghana transport data set. So I don't know how we should organize that.
Sure. What I can do is what you can do is if you do that, just send out that invite to everyone. I send you those emails and just send
Okay.
it out, and we could just name the title optional, and
Okay.
you could just talk about that and just send it out to everyone. So if people can make that Saturday Ghana time, I think that should be excellent. Does that work for everyone? Have people expressed interest?
Yeah, I do. Last week,
Okay.
yes, yeah, last week a couple of, because the last workshop was more of like an image classifier data set,
Yeah.
but some people wanted like an example of like using a data set that is like the transport data set. So I wanted to like make something like that. I have some
Sounds
progress
good.
on it. Yeah. So I'm reading, I have some little progress on API.true.word. You can check out the route trips first. I'm still testing. Okay, Saturday is great. Okay, yeah, that's fine. So is there any question about API, fast API, or just what I'm trying to explain about like inferencing? Like I don't want to give much detail about like the inferencing here, because like the inference is always going to depend on like the model you define or your input, your output. So basically what I'm just trying to do here is just based on like the food classifier model I define, I'm transforming the image exactly the way the model requires it, because like in the input, if you check the model in the training, I'm transforming the model, like you need to crop the model to 256 by 256, because I think it's a requirement for ResNet. And yeah, so this is what I'm doing. Any questions? It could be something unrelated to this, just to make sure you guys are following. Okay, from 1 to 5, how much are you understanding? 1 being you're understanding nothing, and 5 being everything.
1, you're lost in the woods. You're somewhere in China. You don't even know how to get back. You're not even in Ghana anymore. That's the 1. 5, you are good to go. You're in there. You're home. You know what's going on. I see 3. So David is 3. So David is probably in Sierra Leone. Maybe he's in, maybe he's in Cameroon. Dave is 4. So Dave is it? Okay, Dave is in Burkina Faso. Okay, all right. So Dave is close.
Okay.
Ni hao. Great.
Let me see how to simplify this. I try to keep it as simple as possible. Let's see. So normally this is going to change. Well, okay. I think to conclude, I'm going to like explain how to use this main.py file. So if you see above here at the top here, I'm just importing like a couple of stuff required by FastAPI, but I think we're just going to go line by line and I'll try to explain. So this is usually at the top of like any, like usually at the of the fast.api main file. This is just like setting up the login, how much details you want to be logged on your console once you start the API, something like this. Yeah, how much information you want to be logged on your API. So I'm just setting to login.info. I know there's login.debug and a couple of other options. So I'll just take, for example, like in the case where you have your own AI model and you want to use this file. So if I'm coming into this file to use it to create my own API, I'm just going to come here and obviously rename it probably like to my API. I don't know, backend or something like that. Next thing is this config file is just like defining a different configurations that are very peculiar to the model we are currently using. And like, well, this is common, like we are just setting the device to either CUDA if a CUDA device is available, else we fall back to CPU. This image size is because of ResNet. ResNet requires like an image size of 224. So like basically if you have your own model, you just need to like define the different configurations that are required by your model here, or you can just ask ChatGPT what are the configurations. You can just actually ask ChatGPT. I'm not a fan of using ChatGPT, but you can ask ChatGPT just like to write an inference function for your model and to just extract I don't know why this keeps scrolling up. Yeah, you can easily ask Chat once you have defined your model and done everything, you can easily ask ChatGPT to write this function for you, and you can easily just like try to pick all the configurations required to run an inference for your model. So after you define like your configuration, so like the different configurations for your model, you need a function that is going to load your API. Load your model, because the model is supposed to be available on the API for us to be able to like run an inference or to use it to run an inference. So this function, just like the name says, it loads resources. So the first thing I'm trying to load is I'm trying to load this class mapping.json file. And basically, this is what this does. I'm trying to load that. And the second thing is I'm trying to load my model, which is this base model. I first of all like make sure, like one thing you need to note is you need to have like the model in like, okay, you come like in the model.py file, this is where I define like the model. So the model is like the Python implementation of the model or the neural network or of your, I don't know. I guess when I say model, you guys understand what I mean by model. But yeah, this is just like the definition of like the model that was that what I used to train the model. But so I just copied this because you need to use the same model. Like the model was exported in this format. And for me to load the model, I need exactly the same model that was used to train. So that's why I just copied exactly what I had on the Jupyter notebook and I pasted it here. And then I just made sure I install all the dependencies. So I think I missed this command. Yeah, once you get all the files, or like you create your virtual environment, you need to install the dependencies for your project. And for this project, if you check here, the main dependency, the two dependencies required for like FastAPI is this. You need FastAPI and UVCon. So even you can just Google search what you need to install to set up FastAPI. This other stuff is just what is needed by the model. So you have PyTorch, you have Torch Vision for ResNet, you have transformers for loading the bed model, and you have Pillow for image transformation and just modifying images. So very similar here. I just use the torch.load and I load the model, and I just hold on to the model and I return it here. So here I have my model, I have the tokenizer, I have the transform, and I have the mapping. So what maps the ID to the class, and I just make sure this is run when. So if you have your own model, once you try to like identify the components that needs to run or that needs to load your model, you have to like just come in and modify this function to load the model and everything that is needed by your model, or everything that will need to load a model. Because if you see, after I've run this function, I have this model which I can now just call to run the predict. Because if you remember here on my inference function, I just need the model to run the prediction. So yeah, if you see here, I just need this to be able to pass my image and my text. So once you do that, I'll briefly talk about the caching after this, but let's identify the difference. So after that, you need to like define the object, like the input and the output of your model. So my model receives a text, and it also receives an image. So I define the image here, and I define, you can define, there are a lot of ways you can define it, like the input to like the API endpoint. So with FastAPI, when you do app.post, this is a way of defining a post endpoint. I don't know if I'm supposed to explain what a post, get, put, and delete endpoint are, but you can easily Google that. But the next thing is I'm trying to define the input to my model, which I'm going to pass to this model because I've already loaded my model here. So I'm trying to like define the input, which I'll just do, like I'm just defining a class that is going to hold like the input to my model. This is how you do with like FastAPI. And this is like, who is familiar with TypeScript? So it's a way of defining the type or defining the structure of my input. So I'm just saying text is going to be a string, and by default is going to be image of food. Then my result, what is going to be outputted by my model, is going to be a class name, which is a string, the probability, which is how sure the model is, and no, the probability, what is the difference? I'm not even sure. What's the difference between the confidence and, I guess we'll find out. Let's see if there was an output here. I don't remember what we have. I think it's the same. Yeah, the confidence and the probability should be the same. I think the confidence is in percentage and probability is just in number, if I'm not wrong. Yeah. Next thing is, yeah, prediction response. I'm just making sure my prediction should be a list of this prediction result. I don't think it's necessary for me to deploy to explain code, but yeah. At the end of the day, what I'm trying to do is like this input or this API or this endpoint, which is called predict, is going to be my main inference API or endpoint. And what I'm trying to do is like I'm trying to receive an image and also a text from the request. So the way you get the request, or the way you get a text, is you use the request dot text or the request body. You get it from the request body. So this is the way of getting like the text that is going to be passed to my model, and this is a way of getting like the image. Sorry, this is a way of getting the image. So depending on the framework you use, with Flask is going to be a little bit different, but it's, you just need to like probably Google how to get image as an input of an endpoint in Flask, and it should be easy. Excuse me. After that, I don't think I'll explain much about the cache because the cache was just an example, but I'm going to explain what it does, or maybe should I? But I don't know. Let me pause right there. So question, I guess we can do like how much you understand. If you have a question you ask, who wants, like, should I dive deep into like what I'm trying to do here in caching? because this is a basic implementation, there are a lot more things that can be done with caching, but I want to know if I should explain what I'm trying to do here, or if somebody understands, or like who knows what caching is, what's the meaning of caching. I think we should start there. This is the best time you can just go and ask ChatGPT what is caching. So nobody knows what caching is. Why am I talking a lot? Story more access data. Yeah, go
Read the
ahead,
comment.
Godfrey.
What I know about caching is that caching is more like, let's say you have a database and then you really want to have like an easy retrieval whereby some of the data is kind of like being soft saved somewhere else so that you won't always have to go to your data sets or your data models to collect data back again. I think that's what cache is for.
Yeah, exactly. The reason I'm trying to the reason you definitely you need to like implement caching for your model is because, like, for example, like I said, this is like a 1.6 gigabyte file, and or running inference is costly. So what you usually want to do is you want to find a way of saving computation. So for example, like in this code, I implemented like a basic caching to make sure that if somebody is submitting an input that is the same, like the same input, I don't want to run again, like I don't want to run an inference again because I already have that result. So currently here, I'm just saving like the result in memory. It's called an in-memory caching because I'm saving the caching in the Python memory, if I can put it like in a basic term, so that once the app is running, if somebody calls like an inference or makes an inference with a specific image and text, I'll show you guys that it's not going to like go through the model again to do another inference. It's just going to return that result, which saves you compute. Because if not, it means each time somebody calls the model, it's always going to be with like using a lot of compute, which you can just like easily like I don't know, skip that if you save or if you implement caching. So at the end of the day, I'm just preparing the image and the text to pass into into the model and to get like the probability and the classes, or like to get a prediction. So this doesn't need like to be explained like line by line because it's basically like very specific to this. But I'm just like trying to extract the output from the model, and I'm just preparing it to be written by my API. So yeah, at the end of the day, these are just a couple of things that I think you can easily go through and try to figure it out, or ask like I don't know, or just try to like read what is happening here. Like the file is not long, it's just like 198 lines, and it's basically just trying to load the model and to run an inference when somebody calls this endpoint. So what is nice about FastAPI is that once you properly once you define like the input and the output of your endpoint, and you have like an endpoint with app.post, FastAPI automatically creates a documentation for you. So that's one advantage of FastAPI. So for example, I do not have to do anything. Once I implemented my backend and I just run it, it comes with this is called Swagger UI, right? Yeah, I think it's Swagger UI. Yeah, so it just comes with this nice UI, which you can see if I click on try here, it's going to give me an input field to upload the image and another field to like type in the text, and I can quickly test my model. So yeah, I think I'll pause there. After that, we're just going to like test the model and the endpoint. And if anybody have like any specific question that can help them in creating their own API for their project, then he or she can go ahead. Yep. Okay, feels like nobody's understanding. Okay, from 1 to 5, how much are you understanding? It seems like I'm all alone right now. Is it too complicated, or
I
is
say
there any,
three.
yeah, if there is there anything specific you want me to explain? Because there's so much to explain, and I'm just trying to like give as much
Pain.
detail I
Repeat your
think.
question. Pain. Repeat your question. I'm seeing a couple of fours. You know.
Oh, I'm saying if you have any question, feel free to ask. Specifically, like I said, this is like a template for you to help you probably like to build your own API. So if you're building your own project and you have like any issues or any questions that you can like ask to help you adapt this for your own API, ask and I'll try to answer. Yep, go ahead, Godfrey.
Okay. My I'm David, by the way, though.
Oh yeah, okay, Dave, yeah, sorry. Go ahead. Dave, can you get me?
Mic is clear. Sometimes.
Can you
Okay,
say that
so
again?
okay, yeah, I was saying that. Please, one
Yep.
second. People say they can't hear me too clearly, so I was just making sure that everyone could hear me.
Yeah, I can get you now. Hello?
Let's assume that we are done with the model. In this case, for instance, I just finished working on a model and it's uploaded to Hugging Face.
Yep.
So I was thinking about using Hugging Face as an inference endpoint. So I had this idea that I would
Yep.
use before I saw this thing about FastAPI. I had this idea that I'll use Vercel or even Cloud Cloud Run. Was it Cloud Run? In my head, I was thinking that Cloud Run or the other one, Firebase. Yes. So either way, I could run a container with some Flags app in Cloud Run, or I could just do something in Firebase that's just had a front end, and then it could connect to that container, and then off we go. Or I was thinking using Vercel, which is something I've been using a lot more recently, to handle like that kind of container, and then in that container will contain the Flags application, which will then um, connect to the Hugging Face endpoint. So the when you send a user sends a request to the Flask application, which is in that container, that's my API endpoint to the user side. Then the container from the container, the code there would then make would make a request to the inference endpoint on Hugging Face, and then the inference can be or the data or information, whatever it is, can be acquired from there. I'm still fairly new to this, so I'm just putting my idea forward. I'm just wondering if this is something that is okay, or if I should be looking at this from a different angle.
My first question is, I don't think you can use Vercel to run like something like Python, except I'm wrong, because you're
Actually,
saying you want,
no, I use it to run Python applications. I've been doing that for
how
a
do you do
while.
that?
That's why I had the
Wow.
idea.
Vercel, really? That's interesting. Wow, I did
Yes.
not know. Wow, okay.
It's not
Okay,
something
in
that
their
they
run,
normally have, but it's there.
okay, in their runtime isn't quite with Vercel functions. Oh, okay, I understand. It's
It's
like,
Flask.
yeah, yeah. Yeah, you can use Flask. I don't know how, I've never tested it, but I think it can work because as long as you have like a file, for example, like this main.py file, where you can define the endpoint and make sure if you can upload, you can pass in like the input and it gets you the output, then yes, you can do that. But the only issue in this case is like it depends on your model. Hmm. Yeah, you probably need to test, but
Okay.
if you can run Python, you can try, but I think it might be limited. For example, if you're loading like a model like this, 1.2 gig, I don't think VSF might let you do that. So, okay, yes, if the model is
That's why
hosted on, yeah,
so that's why I was thinking about using the Hugging Face inference endpoint. so that the model will be hosted on Hugging Face, and then I make whenever I need to do like a sort of inference or prediction, I rely on Hugging Face's endpoint. I've not tested this idea. It's just an idea in my head. That's why I'm kind of asking about it, whether or not it's even possible, you know.
Okay, let me think about this. Let's do this. I think to make it simple, like, because right now I see what you're trying to do, and it's complicated because instead of like trying to like make your project better, you're trying to figure out how to deploy it. So let me take off some of that burden. So what you should try to do, right, is to just try to like create, you see this example I've given you, right? Try to like adapt your model to run with this. And then, are you going to be using the front end to consume the API?
For now, I've not gotten to that point yet. I'm still pretty much on the back end, but I think eventually that would also come in.
Then why are you building an API? I'm just trying to understand, like, have more context to see why are you building an
For
API?
the API side, I believe I was looking at the tasks that we have to do within the for the classification of the
Yeah,
images, and then also for the transport data as well. In both case, in especially with the transport data, eventually we would need to create some kind of front end to at least demonstrate the idea we have, and also with the classification as well, just so we can show that in terms
yeah.
of maybe just prototyping some usability or something like that, so that you can see that, oh, when the farmer takes a picture, this is how the image goes through this system, and then it gets to this point where inference happens, and even to show how fast maybe that inference might be occurring or something like that, just as a prototyping idea basically.
All right, sounds good. So to just keep it like simple for everyone, there's no need to like try to figure out, like, especially for your backend and to run the inference. I know all of that can be difficult. So, and that's why I said if you're training, you're trying to demonstrate like your project, you can train on a very like a small sample of the data set just to show that it works. And then in terms of like I said, I'm going to be providing a template, like we're going to be giving you guys access to like a GPU to maybe train the model even further, just like see in terms of like the accuracy or the performance you can get. But for your demo, obviously you might not have like a something I you might not have like something that can run the model easily. So ideally, you maybe want to like use like a very minimized version of like your model, probably like something you train on, I don't know, 500 samples. And to keep it simple and to save you time, don't bother about like trying to like host it on Vercel or like, I mean, trying to like, especially for the model part of things or the backend part of things, don't waste so much time trying to like think of like maybe run pod or other stuff. If you want to like spend time and deploy it on that or on something like that, please go ahead. But I think it's going to like be difficult for you because most of my premise, like even like loading this into memory might be difficult. So to keep it simple for everyone, just try as much as possible to use this template to build your inference API. So starting from like just figure out how to like update the model.py file and then trying to like update this file to actually run your prediction on your model locally. After you've done this, the next step is if we need to like deploy it online, I'm going to help you guys deploy it. But the main thing is like if you can follow this template, make sure the main.py works and the model.py works, and you can run the file locally on a very minimal version of your model. Like I said, if there's a need to like deploy it on a production ready server, then I can easily just like grab this. I'll probably, depending on how it goes, but like I said, ideally just try to like adapt your model to run with this. If you have any questions, like I'm providing this template because if you have any question or anything specific, you can just like use Slack, ask a question, tag me, and I'll try to answer as soon as possible. But the goal is like if you're using this, it means if there's the need of like deploying it anytime soon, I'll just like provide a Docker image and I'll easily deploy. I can even deploy multiple projects easily. Like if there's a need for that. So I do just like use this and don't bother too much about like which platform you're going to use to deploy. Because if you have this API running locally with your model, you can easily demonstrate like that your model is working. So I hope that answers your question. Because you're not going to be
Yes.
graded. Yeah, because you're not going to be graded
Sorry.
on like the infrastructure, how you set it up, except if it's a unique, if your project is like has something like a unique advantage of you trying to maybe like show how your model can be deployed on Vercel. If it's part of your project, then it makes sense like have a minimal version. But ideally, just try to like adapt this main.py file to work for your model. If you have any question, ask me and I'll try to answer as soon as possible. And like I said, if there's a
Very
need
good.
to deploy, yeah, if there's a need to deploy it to like a like publicly have a public API, then we can easily do that. I'm just going to add a Docker file here to make it easy if I need to like deploy it. And if everybody is submitting like their API, or if like a select group of people are submitting their API, we can easily deploy that. So ideally, don't bother about that. Focus on like building, making your project or refining your project, and try to like follow this to build your API. If you're using Gradio or Streamlight, feel free to use that, and then we'll figure out like if there's a need to deploy it in like on a public URL later on, we are going to let you guys know, but you're not really going to be graded on that. So it's just about like, can you show that the API, if you have a front end or a user interface, can you actually interact with the backend and something like that? It's just about setting up that minimal infrastructure. And that's why I see all the workshops that we have had, it's like trying to like show you how to like set up that infrastructure, from like how to probably start building your model and how to like create like an API for it, how to run training. Like I said, we are going to have a bonus workshop, which I think is next week, and it's just going to be a very short workshop. I'll just provide a template with which is
Wait,
a
you said
Python
next week
folder.
on this Saturday.
No, no,
This Saturday.
no, that's different. Like I'm just saying, I'm just going to provide a template which they can just
Oh.
like use to send like a file for training. Like it's
Okay.
basically just a file or something like that. So yeah, hope that answers your question, and maybe anybody who had another question. Where can we find the link to the Slack channel? And can you please drop the link to the GitHub link here? Yeah, probably yeah.
I'll drop the link. Payne, you could do the GitHub, and I'll drop the link to the Slack channel.
All right. Yep. Any other questions? Like I said, it can be part like start thinking about your project and how you're going to like maybe deploy it. If there's a specific question you have here that, oh, how can you modify this section? Those are the type of questions you can ask, and I'll try to like answer. Yep, go ahead, Chris. Yeah, go ahead, Chris. If you're speaking, you're on mute.
Okay, can you hear me?
Yeah, I can get you.
Okay, so just about 30 minutes ago, almost 15 minutes ago, I had a data disconnection, and I just made a conversation my brother was trying to ask. But I just wanted to be sure, because I'm done with mine, and I didn't use the FastAPI, but I rather
Yeah.
use Django. Then, as I'm speaking, I've deployed it on Render.
Yeah, if you've done that, that's totally fine. I'm just saying for anybody, like if you have to do that, then do it. And if you're comfortable, because not everybody will be comfortable with like not everybody will be comfortable with like backend. So for example, if you're somebody that struggle with backend, or your I don't know, your team, there's nobody in your team, we can use this is like as a template for you to like say, oh, how can I adapt my model to do this? If you haven't working with Django, fine. If you have deployed it, I guess that's fine too. As long as you're able to demonstrate that it works.
Okay, sure. Thank you.
Yep. Okay. I guess nobody is interested in seeing my API working. So yeah, go ahead, Dave.
Okay, so one last question. Uh, I was wondering one thing. Based on the explanation you gave, I was also looking at the way the our tasks were structured in the documentation that were provided, and it seems
Yep.
in more ways we are supposed to focus more on the models that we are creating and less on, like, let's say, kind of like creating a front end or an app. I think even in both cases, both for the the crop data, the plant classification, and then also for the transportation system. In both cases, like, we need to rather focus on the analytics side and the creation of our models rather than um, on creating, like, let's say, front ends and back ends for them. Am I right in this assumption?
Yes and no. Let me just get something to explain to you. Where is that? I think the judging criteria is somewhere. Yeah. Technical complexity, impact, feasibility. So at the end of the day, right, in whatever project you're building, somebody wants to make sure your project is usable and they can see it. So for you to know exactly what you should focus more on your project, you should think about, like, how is my project unique? So I think on the document or somewhere I explained there was a sample project I gave. So for example, if my project is a model that can be used, like if I'm trying to build like a cluster or a model cluster, or an easy way which we can have a centralized model that multiple farmers can upload images, and then the model, it triggers training of the model, and all of the people that are contributing to that model can have access to it. I can probably like work on the model. In fact, the unique part of this solution is the fact that multiple people can contribute data to the model, and the model can automatically train, and have those people have access to it, which means that's the unique aspect of my project. So you can build a model probably like to an 8% accuracy, or just like to a baseline good model, or even use ResNet. But the unique value proposition of your project is that somebody from a phone or from whatever part of like Ghana can easily just upload an image, and then he can also like access the model. That's the unique part of your project, and that's the part you need to like focus on setting up. So for example, if you need to like present this project, you need to present the project with probably like two devices, maybe like one person with a phone, one person with a laptop, another person with another, I don't know, another device. You show how somebody can upload an image and then also get access to the final train model. So like that's what you need to demonstrate for your project, which might be different for somebody else that has like another person can be building a model that is meant to be predicting the best route you can use in Ghana, or like based on some input parameters, is going to predict the best route. So in that case, your model can be like, okay, how accurate can my model be? So you're going to be focused on like making sure your model is as accurate as possible, and you can achieve the highest accuracy as possible, while giving comments on like, okay, for me to push the accuracy even further, I need more data, I need more compute, I need this, and you should be able to like explain it using like examples. You can say, okay, after training for 500 samples, this is what I got, this is the accuracy I got. So ideally, if I train again on this, I could get this. So you're seeing that like for different projects, that different aspect you need to focus on to show your uniqueness. So it really depends on your project, and you really need to like try to focus on how unique your project is. That's where the innovation part comes into place. Then now the technical complexity can come into like, how do you set up, like, for example, the project where there are multiple people connected. The technical complexity of a project can be like, how did you set up that? On the other aspect, where somebody is focused on like the accuracy of the model, the technical complexity is going to be like, how did you achieve this high accuracy? And you need to like show maybe a baseline accuracy. You can say, okay, on the baseline accuracy when using ResNet is like 89.5. I was able to push this up to like 99. That's where your model becomes, when that's the uniqueness of your project. I hope that answers your question. So you need to like try to tackle what makes your project unique. If you come to the impact part of things, somebody that probably built a model that improved accuracy is not going to be saying that my model, like the accuracy, because my accuracy has increased, more people are going to use my model. I don't think that's a right way to like measure impact in terms of accuracy. If you improve the accuracy of a model or something or prediction, the impact is that it can be used for academic, like by other people to like, it's just like a technical advancement in terms of like education or contribution. But somebody that probably like built a model that can be accessed by multiple farmers, you're going to see that your impact is that you've made the access to I don't know, to an AI model probably easy for people to access it. I hope that makes sense. Yeah, and in terms of feasibility, feasibility is just about like the way you're structuring your demo, because your demo should be trying to show that at the end of the day, this solution can be deployed in Ghana or can be deployed in this region in Ghana, and it can help people. And the end of the day, presentation is just the way you present. So I hope this helps you. So focus on the part that makes your project unique, because that's what is going to make you stand out. Is there any other question? I think we need more Q&A questions to Q&A sessions too. Kevin, that's something we should note.
I got you, boss. I got you.
Any other questions? I guess I'm just going to conclude. I'll just like show you guys the model running, and let's see with the caching mechanism, how can I do this? How do I open a new terminal? Decharged. Okay, there you go. So I'm just going to like do an API request with one of the images, like the image here. I think is this image. So this request uploads this image. Why is this white? Oh, yeah, this request, I'm just trying to like call my endpoint, which is the predict endpoint, with this image and this text. You can also do that with the with this endpoint easily. And yeah, so if I click on that, you're going to see that it's going to take some time. I think this is already a couple of seconds. Okay, it took like a couple of seconds and it returns this. But you're going to see that if I call that same request, I think somebody's mic is echoing. Yeah. Okay. If like you saw that, you might have noticed that if I did that request and it took like a couple of seconds, and if you're on your laptop, it should take probably like a couple of like probably 1 minute. My laptop has some GPU, so that's why it's a bit fast. But if I call the endpoint again, you're going to see that it's going to be instant because it has already cached that result and I'm sending in the same image and the same text. So the model is not being called again and it just instantly returned the result which was stored in memory. So I provided some description on the README. You can read more about like how this works, and there is a better way of setting it up because currently if I stop this API, the current caching system is called in memory because if I stop this caching will not, like, the data is going to be lost. I need to, like, if I rerun the API, it needs to cache again. But there are different ways of like setting up like Redis, which is like database that saves that, but I don't want to dive deep into it. If your project is about how you can improve like the caching of an API or something like that, then that's when you need to focus on that, and you can ask the questions and I can answer that. But I think that should be it for this workshop. So ideally, if you're building an API or you're building your project, you don't know how to like present it, probably like, and you need an API, use this as a template or as a starting point. If you face any question or if you face any issue trying to like convert your model to run on this, post in like, try to like ask the question on Slack, and I'm going to answer as soon as possible. If you're comfortable with any other service like Gradio, Streamline, feel free to use that. But at the end of the day, we just want you to show that somebody that is not technical can easily just grab your project and test it out and it works, or even like shows that it can work. So yeah, I don't know if there's any other question, else we can call it a day. So from 1 to 5, how much did you guys all understand? Like I said, if you have any specification, try to like use the chat, or even like if you have any specification on any of the workshops on how to like, well, the GPU, I don't think you have to like focus more on this, because like I said, we are going to provide like a Python script which you can just copy your code or your what's the name again? Is it a Jupyter notebook code? And then you paste it into it, then you just submit it and like do the training. In fact, I'll give more details on that later on. But if you have any issues setting like your training or workshop, feel free to ask a question and we will try to answer as soon as possible. Just know that I don't think we'll be answering questions on the last day. So because probably you guys are waiting for the last day to start answering questions. Okay, I think I'm going to stop the recording now, and yeah, probably we should have a deadline to stop answering questions. We should probably say next week, Monday, no more questions.
Well, nah, you're so petty for saying next week Monday. That was so petty. Let's do next week. Let's do next week Thursday, right? Nah, because that's Friday, Saturday. Next week Wednesday. Next week Wednesday.
Okay, sounds good.
Cool. All right, you guys, that was awesome. Appreciate you paying as always. Hey, hit the Slack channel, reach out. We're here to support. Remember, next Sunday is the deadline. Saturday we have a